Okay, so in this video we're going to discuss vertex form, and in order to get something in vertex form you need to complete the square. So in our previous videos, if you don't understand how to complete the square, I'd recommend that you go back and rewatch one of those, but that's required to be able to get something in vertex form. So as you can see here, we have this statement where it says, if the coordinates of the vertex of the graph of our standard form for a quadratic are h and k, so the h and k is our vertex, okay? You can represent the parabola as this, and so this is vertex form. And so notice, previous video we talked about transformations. Notice we have this a out front, we have the h, and we have the k. And so just a real quick review, we know that A is going to cause a vertical stretch or compression. Okay, H is going to move left or right, and K is going to move up or down. Okay, so little review regarding our transformations. And so now what we're going to do is we're going to go ahead and do an example where we're going to go ahead and write an equation in vertex form. Okay, so we have the equation y is equal to negative 6x squared plus 72x minus 207. Okay, so it's 207. So the first thing that we're going to do is I'm going to set this guy equal to 0. And I'm going to get it into this form. And notice when we complete the square, we have this little piece here, and that's why we're going to use that process to get it into vertex form. And our first step in completing the square, if you need a little bit of review, you can go back and watch those videos. I'm going to go ahead and move the constant to the other side. So I go ahead and move the 207 over by adding both sides. The next step is we need to get rid of that leading coefficient. So I'm going to go ahead and pull out that negative 6, and that's going to leave me with x squared minus 12x, which is equal to 207. And remember, I'm leaving a gap here because we're going to add in that middle number, b divided by 2 squared. So b divided by 2 is negative 6 squared, so I'm going to add a negative 6 squared on the left side. Remember, one of the things that we had to be careful with is because we have this factor out in front, if we think about going backwards, this factor is actually going to be distributed back in. So we're not actually adding a negative 6 squared, we're adding a negative 6 times negative 6 squared. And so what we're going to get here is we can factor. We had a little trick, and we know that whatever the number is divided by 2, that's going to be what our factor is. So that's going to be x minus 6, and we just write it as a quantity squared. And then we're going to have 207, a negative 207, a positive 207 minus 216. Okay, and I'm going to start to just kind of balance this out. And so we have a negative 6, x minus 6 quantity squared is equal to negative 9. I want to move the constant back over. And this is our vertex form. Okay? So we just got it in vertex form by completing the square. Now, so let's talk about what pieces we have in this equation. Vertex form is it's going to look like this. A times x minus h squared plus k. So our a is equal to negative 6. Our h is equal to 6. Notice how I'm ignoring the negative because they're the same. They're both negative values. And then k is equal to 9. So what does a cause the parabola to do? A causes the parabola to vertically stretch or compress, but because it's 6, it's greater than 1, it's going to be a vertical stretch. The negative causes a reflection over the x-axis. Okay? The 6 is going to cause us to move right 6 units. And the 9 is going to cause us to move up 9 units. Okay? And so now the last thing that we're going to do is we're going to go ahead and draw a generic graph for this guy. And we have our negative 6, x minus 6 quantity squared, plus 9 is equal to y. This is the x value in my vertex, and this is the y. And the sign is always opposite. So we're going to see that our vertex is equal to 6 comma 9. The problem asked for our axis of symmetry. Our axis of symmetry is the equation of the x value. X is equal to 6. And now we're going to go ahead and graph this real quick. And I'm going to go ahead and put a new slide up. And the first one that I'm going to draw in black is our traditional function. Okay, and what we're going to see here is what's going to happen is the vertex is going to move over 6 units to the right and 9 units up. And now, because of that negative 6, we know it's going to stretch and it's going to reflect down. So we're going to go ahead and have a parabola that looks like this in red. And so the vertex form gives us the vertex, and it tells us the type of transformation. And so what we're seeing is we're moving 6 units to the right and 9 units up, plotting our vertex, and then applying the transformations to graph the actual function. We'll do a couple more examples of this because I know it's an involved problem. There's a lot of steps and there's a lot of different things that you have to look at.